In number 1, they give you a graph about how many miles were hiked from a camp. Remember that when you're talking about the greatest rate of change, you're talking about slope. And then from 0 to 1, you notice that the slope was up 2 over 1. From 1 to 2, it was up 1.5 over 1. From 2 to 3, it was up 1 over 1. And then from 3 to 4, it was up 1/2 over 1. So when they're asking for the greatest rate of change, they're looking for the steepest slope. So in this case, it's from hour 0 to hour 1. Number 2, the solution of an equation with two variables x and y is, choice 3 is our answer, the set of all ordered pairs x, y that make the equation true. So for example, the solution to the equation y equals 2x plus 1 is any point of x, y that satisfies this equation. For example, the point 511 satisfies this equation because I plug in 11 for y and 5 in for x. 11 equals 2 times 5 plus 1 is 11, so we see that 11 equals 11. That's true. Therefore, this is a solution to the equation because it makes the equation true. Number 3 is talking about a box plot, which can also be referred to as a box and whisker plot. Cutting right to the chase, number 4, the score that they're asking you which one cannot be determined using a box plot. The score that occurs most frequently, well, that is called the mode, and the box and whisker plot has absolutely nothing to do with mode. So this is why it's choice number 4. Remember, the lowest score is this whisker, the highest score is this whisker, and the median score is this whisker. Quartile 1 is this, and quartile 3 is this. This is also known as quartile 2. Which chart could represent the function f of x equals negative 2x plus 6? What I recommend doing is putting this into your y1 on your calculator and then going to table. You can hit that by hitting second graph in the top right corner. So it's choice number 4 because, like, for example, if I picked my x value to be 4, I would plug in 4 for x, plug in 4 for x, and then when I simplify the right side of this equation, you notice that I get negative 8 plus 6 and negative 2. Therefore, my input of 4 gave me an output of negative 2. Therefore, it's choice number 4. Number 5 can be either thought of as a sequence or just regular function notation. They're basically asking you which of these 4 choices satisfies this function. I'm going to explain to you why it's choice number 2. Kind of like what I did in the last one if you watch that video. If I put in negative 2 for n, then I have to substitute negative 2 for n. So I'll have negative 2 minus 1 squared plus 3 times negative 2. Negative 2 minus 1 squared is going to be negative 3 squared, and then this is going to be plus a negative 6. Negative 3 squared means negative 3 times negative 3, and negative 3 times negative 3 is 9, plus negative 6, I get 3. So therefore, f of negative 2 is 3, which would match our choice number 2. The table below shows 6 students' overall averages and their averages in their math class. If a linear model is applied to this data, which statement best describes a correlation coefficient? What I'm going to do is create a quick scatter plot of this data to give you an idea. I let my x-axis be the overall student average, and my y-axis be the math average. I plotted some points, and if you notice, these points are going up from left to right. They don't seem to form a perfect line, so we're going to say the correlation coefficient is going to be close to positive 1, but not quite 1. So maybe like, I don't know, 0.89 or something. But in regards to these choices, it's saying if a linear model is applied, which statement best describes a correlation coefficient? So in this case, it's going to be close to 1. If it was close to 0.5, it would be like the points would be scattered all over the place, and it wouldn't really form a straight line. Here's an idea of some. This would be an R of 1. This would be like 0.9. This would be like a correlation coefficient of 7. This would be a correlation coefficient of like 0.4. This would be a correlation coefficient of like negative 0.7. This one would be a correlation coefficient of negative 0.9, and this one would be a correlation coefficient of negative 1.